in Workbench, we're going to choose Fluent. Just drag and drop. Make sure the units are in a consistent system from your design software. And then we're going to open Design Modeler. So I will now input my geometry. And this is the helmet primitive. I will now create an enclosure. Now this is a small enclosure, and you'll probably need a bigger than this. You can increase it by changing the numbers, but here we're going just through the steps, so I'm just going to keep to that for now. But this is something that you would need to increase. I then go to Boolean. I go subtract. So target body is the enclosure. And then tool body is the helmet. I choose to maintain the bodies. So the two bodies of the helmet, I want to keep the geometry. And I generate. Right. So now I want to choose some planes. So I enable the plane choosing tool. And I choose the front plane as inlet. Back plane outlet. I'm going to choose surrounding faces. Click, then I turn around. So wall. And I can also choose the helmet as another body. So I choose everything, and then wait the rest of the bodies, the rest of the planes rather. So name selection, helmet. Right. Then I go to mesh. So I'm going to deactivate the helmet for now. And I'm only going to mesh the rest. So you can change various parameters. So you would normally want to do a mesh sensitivity study, but that is changing the mesh until results stabilize and don't change anymore with changing mesh. So you would go finer and finer in that process in terms of the meshing. However, if you're using an educational version, you might have limitations. So for now, we just go to the default settings. Right. And I close this. Then I go to setup. I'm going to update the project so that the mesh gets into the setup. I'm now going to open, choose double precision. Right, so I'm going to run laminar flow. So you might want to check that with your Reynolds number in terms of, so that you can choose a corresponding type of flow. I'm using air for my fluid around the helmet, and I'm going to choose a velocity of 17 meters per second through my inlet. And I am ready to initialize. I will then run the calculation, put 200 iterations. Normally, you might need more in order for the calculations to converge. To a lower value. And now I can get my results. So I can go to post-processing. There's different ways you can show your results. There's potential for animation. So I'm just going to use contours in this case. So I can show velocity. I click on field, and then I can create a plane for my geometry. So I'm going to choose point and normal. I want so this is normal towards the X axis. So I'll click on the plane and the helmet so they both appear. And you can see, so the colors correspond to different velocities around the helmet. So you would need a bigger enclosure to get a more representative view of what's going on, because here the boundary layer is affecting. So you want to reduce the effect of the boundary layer, but you can see where you have lower velocities and higher around the helmet. And you can choose between different variables and different outputs. So you can see pressure, you can see velocity. There's a few options here. You can play around with the outputs to see how and what it is that you want to show and the point you are trying to make.